Okay, now how to recognize AMI? So there are a few signs that can be used to identify or recognize the EMI. So one of the so this slide shows a few types of recognition that can be used to recognize AMI. The first one is inconsistent or erratic readings. For example, vital or sensor data fluctuate without any clinical reason. And secondly, the AMI can be recognized through device works in one area but not uh, in another area. So, which means that uh, the device is location dependent. Eh? So, location dependent malfunctions, for example, it works in test lab, but the medical device fails in ICU, right? And thirdly, intermittent malfunction. So maybe we can see a random reset, freezes, or incorrect behavior without clear cause, right? So meaning that the medical device cannot continuously function. So it has a intermittent syndrome. Sometimes okay, sometimes not okay. So this is known as a intermittent malfunction. eh. And then next, EMI can be recognized through unexplained alarms. And suddenly the medical device produce frequent false alarms or warnings with no patient issues. For example, suddenly the heartbeat of the patient is increasing even though the patient is in a good conditions, right? So this is can be classified as unexplained alarms. And then the AMI also can be recognized through the distorted or missing signals, right? For example, ECG or EKG, pulse oximetry or telemetry data shows artifacts or dropouts. Okay. Next, recognition is through behavior changes near RF sources. And this issue appear when mobile phone, walkie-talkie, or wireless device are bring nearby to the device, right? So after all of this kind of RF sources bring to the near to the device, then suddenly we can see the behavior changes of the device, right? And then we also can recognize the EMI recognitions when the medical device malfunction during electrical storm, right? Suddenly, basically, sometimes when lightning or power surge can cause strange device responses, right? And then the last one, the EMI also can be recognized through communication errors, right? So maybe you can see wireless or wired data links drop or collapse. So how to fix the problem? So what is being done to address EMC and also EMI issues within the healthcare? So what can be? So basically, so there are few key standards that have been created for EMI and also EMC. For example, we have IEC International Standard 60601-1-2, which is for medical electrical equipment and general requirements for safety, collateral standard, electromagnetic compatibility requirement and tests. Secondly, we have IEEE ANSI C63.18, which is American National Standard Institute. So this document recommended practice for an on-site ad hoc test method for estimating radiated electromagnetic immunity of medical devices to specific radio frequency transmitters. And also we have AAMI TIR-18, Association for the Advancement of Medical Instrumentation, AAMI technical information report. So this document is about guidance on electromagnetic compatibility of medical devices for clinical or biomedical engineers. So basically, in order to make sure that the developed medical device is within the standard eh, of EMI and also EMC, so we can refer to these three types of standard, which is IEC 60601-1-2, and then also we have IEEE ANSI 63.18, and also we have AAMI TIR-18. So this document is very important in order for us to ensure that the developed device follow the standard. All right. So according to the Food and Drug Administration guidelines for managing the EMI EMC, there are a few guidelines that has been outlined. The first one, we can see that in order to manage the EMI and EMC, we can establish a policy and process for managing spectrum usage within the healthcare facility. So what this means that we can set up formal rules for how wireless devices such as Wi-Fi, Bluetooth, and telemetry are used in the hospital. So by having this kind of setup of rules, we can prevent interference between the medical equipment and RF sources like phone, routers, and walkie-talkies. And basically, we need to assign frequency band, limit high power transmitter near critical care areas, and we need to monitor for the misuse for including the usage of wireless device in the hospital. All right. So the second guideline given by the FDA is to make use of available resources, such as EMC professionals and publication and internet web pages on the subject of medical device, EMC. All right. So what it means, we leverage the knowledge of EMC engineers, clinical engineers, and also resources from FDA, IEC, and also IEEE, in order to make informed decisions about equipment design, selection, placement, and also the maintenance. Right. And then the third guidelines is by assess the EM environment of the facility and identify areas where critical medical device are used. So this means that we need to evaluate areas like ICU, intensive care unit, and also OR or operating rooms, radiology, and also telemetry units for EMI exposure levels. This is because some zones are more vulnerable in which they host critical life supporting device such as in the ICU. So we need to assess each area because they have different immunity and also different immunity level of EMI and also EMC. So for this purpose, maybe we can perform electromagnetic surveys, and then we can identify high risk zones, and also we can map device vulnerability. By having this kind of thing, then we can identify the critical area that need intensive EMI shield to ensure that the medical device can be function properly. All right. The next FDA guidelines is about coordinate the purchase, installation, service and management of all electrical and electronic equipment and used in the facility to achieve EMC. All right. So in this process, we need to involve EMC or biomedical experts and throughout the device life cycle, and not just during the purchase. So we need to know starting from the uh, receiving of the medical device, and after that, using the medical device, doing maintenance on the medical device, and finally, we need to think about the management of the waste of the medical device. All right. And basically, we also think about poor integration and poor integration of medical device. Can cause EMC's issues, even if each device individually meets standards. So sometimes when we put few medical device in a one place, so we have to make sure that they have electromagnetic compatibility between each other, so that so one medical device will not interrupt other medical device on the same area, right? So in order to achieve that kind of uh, goals, then what we need to do is we need to choose uh, appropriate eh, uh, appropriate device to test the EMC standard for the medical device, such as IEC 60601. And also we need to place the equipment properly, use proper grounding, and also proper shielding, and also the maintenance of the medical device. And also sometimes we need to track and also control the upgrades that may affect the EMC of the device. All right. So another guidelines. Sometimes we need to educate healthcare facility staff, contractors, visitors, and patients about the EMC and EMI, and how they can recognize medical device EMI and help minimize the EMI risk. And then we need to establish and implement written policies and procedures that document the intention and methods of healthcare institution for reducing risk of medical device, EMI, and achieving EMC. And then finally, we can report EMI problems to FDA Medical Watch Program and communicate EMI or EMC experiences to colleagues in open forums such as medical or technical publication and conferences. So in summary, in this topic, we have learned about the EMC definition. We have identified problems caused by EMI. And then we have done some confirmation of EMC and recognition of EMI. And finally, we have discussed about the FDA guidelines for managing EMC and EMI. That's all. Thank you.